In the previous video, we walked through how to determine that the arctangent of 1 is equal to pi over 4. In this video, we're going to determine what arctangent of 2 plus arctangent of 3 is, and then complete this problem of determining the exact value of this sum right here. So let me clear some room. So maybe we can apply the same trick that we used in the last video to determine that the arctangent of 1 is equal to pi over 4. So let's label arctangent of 2 as A, and then arctangent of 3 as B. So let's say if we wanted to determine the arctangent of 2, then we want to determine for what angle A, is it true that when I take the tangent of A, I'm going to get 2? Because remember, tangent of A is the same as tangent of arctangent of 2, which is the same as 2. So in this case, tangent of A is equal to 2. Well, it might not be clear what A is. So let's rewrite this as sine of A over cosine of A, and maybe we could even go further and say that we wanted to determine for what angle A, is it true that sine of A is equal to the 2 times the cosine of A. And this might not be immediate what this is. And in fact, if you were to cheat and use a calculator, you might find out that the arctangent of 2 doesn't have a nice closed form like pi over 4 in the case of arctangent of 1. And the same scenario holds for arctangent of 3. It's not clear. It's not clear how we can use our knowledge of the unit circle like we did when we were determining the arctangent of 1 to determine what the arctangent of 3 is. So we're going to have to go about this in a different technique or a different trick than what we used to determine what the arctangent of 1 was. So maybe one thing we can do is, well, we know something. We know that the tangent of A is equal to 2, and we know that the tangent of B is equal to 3. So maybe we can say something about the sum A plus B. Maybe we can say something about the sum A plus B. Well, what could we say about the sum? Well, maybe we can somehow leverage the fact that we know what tangent of A and tangent of B is, and somehow determine or be able to say something about A plus B. Let me actually phrase this scenario in a different way. So suppose we were in the hypothetical scenario where we knew sine of A, sine of B, cosine of A, and cosine of B, and we wanted to figure out something about A plus B. Well, we could use the angle addition formulas for sine and cosine, because check this out. Sine of A plus B is completely in terms of cosine of A, cosine of B, sine of A, and sine of B, and same with cosine of A plus B. So we could use these trigonometric identities about the sum of two angles when we take the sine of a sum and the cosine of a sum of two angles. And it turns out there's a nice trigonometric identity that's analogous when we're taking the tangent of the sum of two angles. This trigonometric identity says the following: tangent of A plus B is equal to tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. Well, we know tangent of A is 2, we know tangent of B is 3, so this is going to be equal to 2 plus 3 divided by 1 minus 2 times 3, which is 6. So we have 5 divided by negative 5, which is equal to negative 1. And moreover, we know based off of the range of the arctangent function. Remember, A is the arctangent of 2, B is the arctangent of 3, arctangent of 2, arctangent of 3. We know that A and B must lie in between negative pi over 2 and pi over 2, because that's the range of the arctangent function. That is, the arctangent function sends any real number x to some number in between negative pi over 2 and pi over 2. So this tells us that A is less than pi over 2 and greater than negative pi over 2. And same thing with b. b is less than pi over 2 and greater than negative pi over 2. But actually we can say even more. We can say even more because check this out. Check this out. A and B, or aka the arctangent of 2 and the arctangent of 3, are just angles in between negative pi over 2 and pi over 2 on the right half of the unit circle. Now, to see how we use this fact that A and B are angles that lie on the right half of the unit circle, check out part 3 where we finally solve the problem of determining the exact value of arctangent of 1 plus arctangent of 2 plus arctangent of 3.